Today we're going to be talking about inequalities in two triangles. So first we're going to look at a new theorem called the hinge theorem. And this theorem says that if we have two sides of one triangle and they are congruent to two sides of another triangle. So I've redrawn the triangles that they have listed up there, and we're just going to mark these. So we're saying AB is congruent to FG and AC is congruent to FH. Okay, so that's the first part. So you have two sides of a triangle are congruent to two sides of another triangle. Okay. Then it also says the included angle of the first triangle is larger than the included angle of the second triangle. So they've said that on this triangle ABC, that angle A is 43 degrees, and that on triangle FGH, that angle F is 30 degrees. And you're going to notice that's the included angle on both of those triangles. Okay? So we have the included angle of the first triangle is larger than the included triangle or included angle of the second triangle. Okay? Then, what we know, and remember when we start the then portion of a theorem, that's telling us what we can conclude. That's telling us what our answers are going to be. So we have then the third side of the first triangle, that would be this side here, is longer than the third side of the second triangle. Okay, so we're saying then that BC here, so it's the first triangle, it has the bigger angle, is going to be larger or greater than GH, which is the third side of the second triangle over here. Okay. And so all we're interested in here is being able to tell which of those, which third side, or which triangle has the larger third side. Okay. And if we're saying that, triangle ABC is the first triangle and FGH is the second triangle, that's all fine and dandy. What we're really interested in are these included angles. So you have to have two sides on each are congruent. Okay. And then you're looking at that angle, and whichever one has the bigger angle, the side across from that one is going to be the bigger side. So the 43-degree angle is bigger. The side opposite it is BC. It is bigger than the side opposite the 30-degree angle. Okay. We also have the converse of this, so we're going to look at that next. Okay, so this is the converse of the hinge theorem. And remember, the converse turns our original hinge theorem around. It takes the if and the then portions and it swaps them. So this time we're starting off with if two sides of a triangle are congruent to two sides of another triangle. Okay, so we still have to have that. So JL is congruent to PR and LK is congruent to RQ. And the third side in the first triangle, so notice this time we're dealing with a side here. Okay. The third side is longer than the third side in the second triangle. So here, the longer side is side 12. It's bigger than the side 8 over here. Okay. It's longer than the third side in the second triangle. Then, the then is going to tell us what our conclusion is. So then, the included angle measure of the first triangle is greater than the included angle measure in the second triangle. So what that's telling us is that this angle R, which is across from this bigger side here, is bigger. It's larger than or greater than. This angle L over here, which is across from the third side, which had an angle measurement, had a side measurement of 8. So that was angle L. So again, you're just looking, and we have to verify first that they each have two sides that are congruent. So if we didn't have JL was congruent to PR and you didn't have LK was congruent to RQ, then this would not apply. It only applies to triangles where they have two sides are congruent. And then on this one, when you look at that third side, you actually have to know which one is bigger. It has to tell you. And that will lead you so that you can look. And the angle across from the bigger of those two sides then will be the bigger angle. So we know that angle R is bigger than angle L. Okay? So let's look at an example together. So here I have two triangles, and remember the first thing we have to check is going to be, do they have two sides that are congruent? So I can see here AC is congruent to BC, got those labeled, and I'm looking for a second side that's congruent, and nothing is marked specifically on here. That's because, remember this middle line where they both share this line? Because it's the same line for both triangles, that means it is congruent to itself, right? It can't be 15 feet for one triangle and then 13 feet for another. It has to be the same measurement because it's exactly the same line. So we have two sides that are congruent for both triangles. And then we're looking at the angle measurements, and we want to know which angle is bigger. So you have to think, is 70 bigger or is 68 bigger? Okay, 70 is bigger. That means that the side across from it is the bigger side. So that means AD is bigger than the side across from the smaller angle, which was the 68-degree angle. So AD is bigger than BD. Okay. And the order of those doesn't matter. If you had called them DA and DB instead, it would still be fine. No problem there. Okay. So we know that side AD is greater than the side BD. So let's look at another example. This one used the hinge theorem. Let's look at one that uses the converse of the hinge theorem. Okay. So again, here, the first thing we still check is, do we have two sides on each triangle that are congruent? And I see that AB and DC are congruent. And again, I see that both triangles share this side BD. So that is going to be congruent to itself, right? It's the same line for both triangles. And so this time I'm looking at the third side of each triangle. So on triangle ABD on the left, I see that this side's measurement is 5.5. And for triangle BCD, I see that this third side's measurement is just 5. So you have to think, which of those is bigger? Okay? The 5.5 is the bigger side. That means that the angle across from it is the larger angle. So that means angle B.
Caitlin Adams, if you're in the building, your cell phone is in the South Bridge room. Caitlin Adams.
The angle across from the smaller side, which was 5. So that is angle D. Okay? So that is an example of the converse of the hinge theorem. Right? So not super difficult. And we'll work out some more examples tomorrow in class, and I'll answer any questions that you have. And I really appreciate you watching today. Thank you very much. Have a lovely afternoon.